This is going to be question number 2. Okay, you have this question about completing the table to give the formula and acid-base behavior of some of the oxides on the period 3 elements. Now, so you have sodium oxide, okay, aluminium oxide, silicon oxide, okay, phosphorus oxide, okay, and then you have sulfur trioxide over there. So can you actually give me the oxides of aluminium? Gabriela, Nicole. Oxide of sodium is Na2O. How about oxide of aluminium?
Aluminium, yeah.
Yes.
Al2O3.
Okay, very good. Al2O3. Silicon, Justin.
SiO2.
Okay, SiO2. Phosphorus. Jason. How about Janice?
First answer, P2O3.
No, it's not P2O3. You can refer to textbook page 154. Nicole, Tricia?
Is it P4O10?
Yes, okay, it's P4O10. Okay, P4O10. So let's actually talk about the acid-base behavior. Na2O, what can you say? Is it acidic, is it basic, or is it amphoteric? So Victoria?
Basic.
Okay, group 1, okay, group 1 and group 2, okay, they will actually have the basic oxide, yeah. So silicon, what can you say about silicon, Arnetta?
Acidic.
Okay, it's acidic. Okay, Lavi, what can you say about phosphorus oxide?
Acidic.
Okay, acidic. Shane, what can you say about the sulfur oxide, sulfur trioxide, and also sulfur
Acidic.
dioxide? Yeah, so this one is acidic. Okay, take note of this. Okay, now group 2 elements form stable hydroxide, okay, with general formula of MOH2, where M is the group 2 element. So one of it is beryllium hydroxide, and they say that it's an amphoteric compound, okay, that shows similar chemical reactions to aluminium oxide. Okay, so they have mentioned that this one is quite special. Okay, beryllium hydroxide is amphoteric compound. So state the meaning of the term amphoteric. Okay, Gabriela, Nicole, can you tell us what is the meaning of amphoteric?
Reacts with both acid and base.
Okay, so can react with both acid and base. Okay, that's going to give you 1 mark. Jody, write an ionic equation for the reaction of magnesium hydroxide with hydrochloric acid. Okay, before we write the ionic equation, Jody, can you actually tell me the full equation? MgOH2 plus HCl will give you
MgCl plus H2O.
MgCl2 plus H2O. So when you balance, you will have this as 2 there. Hydrogen, I think there's 4, so you need to actually have 2 over here. Okay, so writing the ionic equation, how do we write the ionic equation, Jody?
OH minus plus H plus equals to H2O.
Okay, do you know how or why we actually get that? Maybe some of you still do not know, yeah? Okay, I'll just show you over here. Magnesium hydroxide is aqueous. HCl is aqueous. Magnesium chloride is aqueous. This one is liquid. So when you want to actually change it into ionic equation, what we do is we actually separate them into ions first. So you have Mg2 plus 2OH minus, okay? When they dissolve in water, they will give you this. Aqueous, when they dissolve, 2H plus and then 2Cl minus, they will get this. Magnesium chloride is also aqueous, so Mg2 plus and then 2Cl minus. Do remember liquid, okay, liquid, gas, or solid, they do not actually break into the ions when they dissolve in water. So in this case, okay, they are going to stay as 2H2O, nothing changed. Now, the next step is to actually eliminate some things, okay. I am going to actually eliminate Mg2 plus and Mg2 plus because under this reaction, okay, there is something that is happening, but Mg2 plus is still going to behave as Mg2 plus and 2Cl minus still behaving as 2Cl minus. It means we call all these ions as I circled just now. What are the name that we use for those ions, Arnetta? There's a special name for them. The one that I do not even write, the one that I can cancel, there's a special name for that. Arnetta, if you do not know, just say no. We can continue with other people.
Sure.
Yeah. Cannot hear. Maybe we'll try. Yeah. Did you mention spectator ion? Okay, the ion's name. Okay.
No.
Yeah. So the ion's name is spectator ion. Okay, they do not take part in the reaction. So they are spectator ion. Okay, so we do not actually include them, okay, in this. So therefore, okay, you are going to actually have, okay, 2OH minus plus 2H plus to give you 2H2O. So we do not need the 2 over here. We can cancel the 2. So therefore, your final answer, okay, is going to be, you can write down H plus OH minus to give you H2O. Okay, please do the same thing when you have a similar question in future, right? So this one is very simple because neutralization, they always have that kind of ionic equation, okay, the one that we did just now. Okay, but some situation, I give you one example. Okay, if I have, let's say I'm going to form AgCl, and AgCl I'm going to get from silver nitrate. Let's say silver nitrate react with ACl. Okay, so silver nitrate react with ACl. Okay, let's say not ACl. Let's actually change it into NaCl. Silver nitrate reacting with NaCl, you are going to get silver chloride. So Lavi, what will be the other product that will be formed over here? Possible product.
Sodium nitrate.
Okay, sodium nitrate. Now, what can you say about the states? Okay, so Charlton, silver nitrate, is it aqueous or solid?
Aqueous.
Yeah, all nitrate salts are soluble, so take note. All sodium salts are soluble, therefore they are also aqueous. What can you say about silver chloride? Justin?
Solid.
Okay, silver chloride is always solid. If you don't remember, please actually try to remember this. Silver chloride, silver bromide, silver iodide. Okay, these are the one that we will use also for paper 3. Okay, where they will actually form a white precipitate, a cream precipitate, and then a yellow precipitate. Okay, very important. Okay, very important. So here they are going to be precipitate, so therefore it's solid. And then here is going to be all nitrate salts or all sodium salts, they are soluble, so it's aqueous. Now, if I ask you to actually write down the ionic equation for this, Janice, what will be the ionic equation for this?
Ag plus NO3 minus equals to Ag plus Cl plus solid.
Actually, it's like this. Okay, this is what I told you. If it is aqueous, just write down Ag plus NO3 minus. But once you are very good at it, I think you no need to write down like this. Okay, so plus Cl minus to give you AgCl. Do remember we cannot separate the solid. Yeah, so you are going to get Na plus and then NO3 minus. So the spectator ion that we are talking about, this is a spectator ion. Na plus is a spectator ion. So left with Ag plus Cl minus to give you AgCl. Solid, aqueous, aqueous. Take note of this. Okay, this is how you write down the ionic equation. Okay, now, so let's actually move on. Okay, here you have two methods of preparing strontium hydroxides are shown. So basically you are going to actually get strontium reacting with water, going to give you strontium hydroxide, or strontium oxide when reacts with water also give you a strontium hydroxide. But they ask you what is the one difference between the observation that you will make for reaction 1 and reaction 2. So in order to answer this, okay, let's actually identify the reaction that is going to happen. Okay, strontium is in which group? Okay, I want you to find out this first. Charlton, strontium is in which group?
Wait.
Anyway, one of the main thing that you need to refer is your periodic table. But okay, also you can refer also in the question itself, yeah. Okay, but if you are not sure, okay, but generally please refer to your periodic table. Okay, strontium. Yeah, we'll wait for Charlton.
Group 2.
Yeah, very good. Okay, it's group 2, yeah. So group 2, okay, when you have group 2, okay, reacting with water, okay, reacting with water, strontium with water, what do you think, okay, what do you think will happen? What do you think? I think it's similar to the one sodium plus water, magnesium plus water. What do you have? Victoria, what do you have? Sodium plus water, magnesium plus water. Metal plus water, what do you get?
Is it produce bubbles?
Yeah, but before we go there, let's actually write down the equation, yeah? So of course it's going to be NaOH plus what?
NaOH plus H2.
Yeah, hydrogen. So the same thing here, magnesium hydroxide plus H2. So this is also group 2, so must follow the magnesium, yeah? So strontium plus H2O will give you strontium hydroxide plus H2. Okay, it's not balanced yet. Okay, it's not balanced yet. So if I want to actually balance this, I'll put 2 here. Okay, and then now it's already balanced. How about reaction 2? Okay, reaction 2. Let's say if you're not sure, please actually refer, let's say, strontium oxide. I'm not sure. Okay, let's actually try out sodium oxide or magnesium oxide. When I add with water, what do I get? Arnetta, what do you get? Sodium oxide or magnesium oxide add with water?
Sodium hydroxide.
Yes, straight away you will get sodium hydroxide. Straight away you will get magnesium hydroxide. There's no other products will be actually formed. Okay, of course you need to balance that. Okay, so that one we leave it over there. I will try to balance this equation. Okay, so you have strontium oxide. Okay, strontium oxide plus H2O. You are expecting to get strontium hydroxide. So if I want to balance this, okay, I think it's already balanced. Okay, it's already balanced. 2H, 2O, okay, it's already balanced. So what is the one difference between the observation that you make for reaction 1 and reaction 2? So Charlton, what is your observation that you think that will be suitable for this?
Make pop sound when have lighted splint.
Okay, that is correct. Okay, definitely that is correct, Charlton. Okay, but do remember this. They didn't ask you to test with lighted wooden splint. Okay, but possible. Okay, possible if you write. Okay, I'm not sure during that year did they accept that answer. Okay, but for me, the best answer should be like this. When they say observation, if they say what is your observation when tested with lighted wooden splint, then your answer is correct. Okay, but when they say observation, when you have this thing reacting without doing anything, what is the observation that you can observe? Okay, the only observation that I can think of, yes, there is gas over here, there is no gas. So whenever there is gas, so we will follow what Victoria said, there will be gas bubbles will be formed. Or in chemistry, I do not want any more gas bubbles. Okay, I want, what is the term that we're supposed to be using, Victoria?
Effervescence.
Yes, please actually write effervescence. And how do you spell that, Jody?
EFFERVERSENC.
VES, yeah. VES. Okay, then CENCE. Okay, effervescence. So when I check with the marking key, yeah, so this one I told you I will check with the marking key, Charlton. According to the marking key, that answer is not accepted because according to the question, they didn't ask you to do for the test. It's just an observation directly. So it's only effervescence. So you will see effervescence for reaction 1. That's it. Okay. State how the solubility of group 2 hydroxide changes down the group. I think last time when we did this MCQ question, also in the same paper, I mentioned about this. Okay. Solubility, okay, when you go down, okay, if it is sulfate and if you have hydroxide, okay, I told you to memorize this. Sulfate, the solubility will decrease. Hydroxide, the solubility of group 2 will increase. Okay, so this one is solubility is going to increase down the group. Okay, but do remember this one I told you for AS is enough to memorize. Okay, but okay, imagine now you this question came out in A2 and they ask you what is the reason. Okay, if they ask you for what is the reason, let's focus on hydroxide. Yeah. Okay, let's focus on hydroxide. If let's say they ask you to explain why the solubility of hydroxide actually increase. Okay, so in A2, okay, in A2 what we say is the decrease, okay, is the other way around that we actually learn, yeah, the decrease of lattice energy. Okay, and then you compare with the decrease of hydration energy. Okay, do remember if it is sulfate, we say, okay, we say the hydration decrease more. But in this case, lattice energy decrease more, okay, compared to the decrease in hydration energy. Okay, it means the decrease of lattice energy is more compared to the decrease in hydration, and that makes your enthalpy of solution, okay, that makes your enthalpy of solution to be more endothermic. When it is more endothermic, this one is more soluble, yeah, so it's going to actually make it more exothermic. So if it is more exothermic, it is more soluble. Okay. So if they ask you related to sulfate, okay, why the solubility decreases down the group, you can say that the decrease in hydration energy is more compared to the decrease in lattice energy, and that actually makes your enthalpy of solution to become more endothermic. Therefore, it will become insoluble. Okay, please actually memorize this, yeah. Okay, please really please memorize this, because this is definitely one of the popular question when it comes to A2. Okay, let's actually learn now itself, yeah. So in your syllabus and in your textbook, they have mentioned for this, but in past year paper, okay, they have mentioned about this. They have tested for hydroxide before, so you just need to change it a bit. Okay, next one. So you have sodium peroxide reacting with carbon dioxide to give you sodium carbonate and oxygen. Partial pressure, okay, is given. Okay, these are the details. Okay, calculate the amount of moles, okay, of carbon dioxide present in the sample of air at 20 degrees Celsius. So how to calculate? Okay, what do we use, Gabriela, Nico?
Is it PV equals to nRT?
Yes, that's the only way that we can do. Yeah, there is no way to calculate just using the volume alone. Yeah, so they didn't actually say if you want to use volume alone, then it must be standard. It must be room temperature and pressure. It means we know that 1 mole is 24 dm cube. Okay, if you are asking why we cannot use that, okay, we cannot use that because that is actually for room temperature, and of course 20 degrees is not room temperature. Okay, we cannot use that. So this one we will assume that carbon dioxide is an ideal gas, so we will use PV equals to nRT. Okay, this one we have discussed before. Yeah, Janice, tell me the P, what is the value that I will use? What do I write?
5.37 times 10 power 3.
Yes, very good. Change it into Pascal. Volume, Jason. Hurry up. You need to change it into what?
CMQ.
No. Okay, Jason, memorize there. It must be meter cube. Okay. So how do you change this to meter cube, Jody?
Times 10 power negative 3.
Okay. So basically it's going to be D is going to be deci is going to be 10 negative 1. Yeah. So 10 negative 1 3 times. So you need to actually divide by 1000. 1 dm cube actually has 1000 meter cube. Okay, so you will have 0.5 times 10 negative 3. Number of moles. What is the R value that we will use? Charlton?
8.31.
Very good. 8.31. Temperature, what do we use? Janice?
Yes, sir.
What is our temperature that we will use for the formula?
293.
293, right? Okay, 20 plus 273, so 293. Okay, just in case, always check. Okay, if you're not sure, okay, what is the values? All the values are given in your data booklet. Okay, this is your data booklet. And then they have given you the R value, okay, 8.31. Please take note. Please take note of this as well. For temperature, let's see. I think they would have actually told in the beginning. Okay, even if it's not here, okay, please actually take it as 273 here. Because I think I've seen 273.15 before. Yeah. So this one we will use 273. Okay. So some students, they actually in the past, they use 273.15. It's not correct. Yeah. So take note of that. So it's going to be 293. Okay. I think enough time already. So what is N? Nicole, Tricia, what is N?
Sir, is it 1.1?
Let me check the answer key. Yes, it's 1.1 times 10 negative 3, is it?
Yes, sir.
Yeah. So normally we want 3 significant figures, so you can actually just put it like this. It should be okay. Okay, now the next part is calculate the mass. Okay, calculate the mass of sodium oxide, sodium peroxide that will fully react with the amount of carbon dioxide calculated in iron. So it means the amount of carbon dioxide that I have calculated is 1.1 times 10 negative 3. So I need to find the mass. So of course the number of moles is going to be the same. So number of moles of N2O2 is 1.1 times 10 negative 3. So if I want to find the mass, number of moles is mass over mR. Okay, mass is number of moles times the mR. So times the mR, 2 times 23 plus 2 times 16. 46 plus 32, 78. 78 is 7, 8. So 15, 8, 5, 8. Am I correct? Check. 85.8 times 10 negative 3. 8.58. Please check my working. Okay, I didn't use calculator. Maybe I'm wrong. Okay, I'm correct. Okay, let's see the rest. Okay, the peroxide ion O2 minus, O2 2 minus has a single covalent bond between two oxygen atoms. So oxygen, oxygen, single covalent bond. Each oxygen atom carries a negative charge. So negative, negative. Draw a cross and dot or dot and cross diagram for this peroxide ion. So if it is like this, I think if I want to translate it into cross and dot diagram, quite simple. Oxygen is group 16, so 6 valence electrons supposed to be. So now you have minus, so it means there is one more electron that came in from somewhere. Okay, so the same over here, but they have single bonding over there, so it means one of the electron have to be participating in bonding. So what I do that I can actually simplify this. I will bring this one and I put it somewhere here. So I will draw again. So O, I put 1, and then this one came from somewhere else. So I put like this, and then another O. So I put X. So similar. So this one maybe came from somewhere else. So if I want to draw properly, so let's say I erase this part first. And then now I put the dot and X. And then this one overall, negative charge and negative charge overall will become 2 minus.
Sir, we need to put the 2 minus also, yeah?
Yeah, because it's peroxide ion, yes, need to put. If you want to put another circle also okay. Let me see whether if you don't put, will they minus mark? They don't. Okay, they don't minus mark. You can just leave it like this also can. Okay.